Hello, my name is Esat. So,
You have, if you want to use the portal microphone, that's fine.
my name is Esat. I'm a high school senior, and this is the machine learning part of my project is one thing of a much larger project that I've been developing since sophomore year. But I'll talk a bit more about that later on. Okay, so a general introduction to cyanobacteria as well as the blooms and the major problems that we'll be discussing here. So cyanobacteria is a type of algae. If you don't know what algae are, they are the bacteria, the green bacteria that cover lakes, ponds, other bodies of water, as you can see in that picture over there. And so this is, algal blooms have become one of the most prominent environmental hazards in the modern day due to the overuse of fertilizers and other kinds of pollutants that we have in the waterways. So this has become a major issue, and combating it is going to be very important, and developing new treatments for these algal blooms is going to be crucial in the future. So my work focuses, so there is, I'll show these figures first. There was a mistake there, but so this figure generally shows the progression of my research, so you might be wondering what is going on here. The wing that we're going to focus on today is the top one. The blue box says it's inhibition, everything right of that. So the environmental stuff is what this algae is focused on. There's something wrong with the figure, it's supposed to be colored and not like this, but so basically, there's two aspects to my research. One which I the cyanobacteria that can be used as a major environmental hazard, but we can also exploit it for our own purposes, to our own advantage. And so the part that there's really two sides that we have to address here with this issue. One is cyanobacterial environmental hazard. And so limiting this hazard through an inhibition of their growth is extremely important. And so that whole wing is one aspect of my project. Second one wing is the induction, the part that we can use to create substances such as biofuels, which are another very important developments in the future as we transition to renewable energy. And so the whole bottom stuff, I did that at Yale University with a professor. So this stuff is not what I'm going to be talking about today because it doesn't relate to machine learning algorithm. This is what relates to my biofuel for my research. I'm going to be talking about the top stuff, everything right in the inhibition box. So basically, the inhibition of cyanobacteria growth is beginning to combat this environmental hazard. And what I did was I conducted research to try to find certain treatments and add to the literature, to existing literature, treatments both by themselves and combinations, collect data on this, and basically advance our understanding of how these treatments work together and how they can affect the cyanobacteria in a negative way, their growth, to inhibit and stop their growth. So the next step in this research was to write the machine learning algorithm that is able to take this data that I collected and give it to important usage. And so it's able to make its own analysis, which I'll get into later as well. And using my data, it's able to couple these two and produce suggested treatments for the user, which could be environmental conservationist, or anybody who has a pond or lake or in Okay, so another important part of this project is that the algorithm is open access. It is published in a nonprofit that I co-founded. And so you can, anybody can have access to this algorithm. And so to get into some of the metrics of it, generally with machine learning algorithms, to be competent in the industry, the general standard is anything above 70%, most people say 70 to 90% accuracy is a good amount to be valuable, a viable algorithm. And so my algorithm has accuracy of 77%, but it can not only identify one type of algae, it can identify 5, which are the most commonly found in these algal blooms. So we have blue-green algae, diatoms, Dinoflagellata, Euglenozoa, and green algae. So these are different groups, and in this figure you can see the average precision of the algorithm, so how we can identify these groups by group, etc. Okay, this is a bit more analysis. I'm not going to get into too specifics of this figure, but this is during the training. So both the 3 graphs on the right and the 2 graphs on the left. The 3 graphs on the left and the 2 graphs on the right. They both reach asymptote, and the left graphs, the trained balls loss, sales loss. What they show is basically how accurately you're boxing the bacteria that is present that you're trying to identify. So how much space, when you create a box, that I'm going to show you how the algorithm works after this. How much space you're losing, how much of it are you utilizing correctly. So basically, how accurate can you actually identify bacteria? And then here with the precision and the recall metrics, these are just showing out of the bacteria that is actually present, how much are you able to identify correctly. So this is an example of supervised learning where I'm already providing a data set that is pre-labeled. And so based on what I have given it as an objective, as a standard, what is correct, what is wrong, the algorithm is learning from that to advance itself and to become applicable in the real world industry. Okay, so let's see if this. It's not projecting onto the thing. Yeah.
It's working.
No, it's not.
Oh, okay. What's going on?
It's not projecting there. If it doesn't work, it's fine. I have a backup.
Is it in the PowerPoint or?
Yeah, it's okay. I have a backup, so if you just go back to PowerPoint. This was.
Oh, this one.
No, this one.
What do you tell me?
I need to open the slideshow over here.
You want to show this one?
Yeah.
Just play it.
Okay, this is a demonstration of the algorithm. So in the actual published open access source, this data, this code is not present there. So this is basically an example of how it works. You just saw the input image, and now we're going to run the algorithm. This is the analysis, and down below, above, you're going to see suggested treatment for this constellation. So this is the second type. This is diatoms, another type of algae. So we're running this algorithm, you can see it identifies most of them correctly. There's some, if they have overlapping over one another, it's more difficult for it to identify correctly. But generally, we have a good accuracy and precision, especially since we can identify 5 different classes. Okay. Go back to the slideshow.
This one.
Yeah.
Disons.
How do I go to the next one?
Disons.
Okay. This is just what the video shows in picture format. So you can see down below, based on what has been analyzed on the pictures of the algorithm. What the algorithm looks for is one of the fact types identifying that form of algae that's seen that's observing. Density of the algae which can calculate, and also the average size that it observes here. So based on all these metrics, the cool thing is that this analysis by itself would be pretty useless to someone who is an environmental conservationist or someone who just wants to get rid of algae on their pond. Because you can know the density of the bacteria in your sample, but it's not going to help you in terms of combating the bloom. So the nice thing is that I can use this analysis and couple it with the data that I've collected to basically create these suggested treatments for anybody that wants to have this data and be able to create an applicable usage of this. So you can see on the picture above, it identifies all different types of algae if they're present. In the one above, it has found that there is diabs and there is euglenozoa at different densities, different average size, and based on this, we coupled that with the data that I've collected in my research prior to create suggested treatments. And the one below is the similar. Okay, yeah, this is the thing.
Thank you for this great presentation, Esat. Any questions, comments? Yeah, I have a quick question. So, according to your method, do you think that it can be used in like microbiology area to, because when you have some samples from the patients and you have to identify which kind of bacteria of algae or other the viruses causes the infection. So do you think that it can be used in the same way for the detection of to identify the microorganisms?
So are you asking if we could create a different algorithm or use this one to identify those different
Right.
bacteria?
Right. Yeah.
So using the same algorithm?
Like similar or the same?
So creating a new one, or
Yeah.
could you identify the
Different, not only algae, for example, other bacteria,
yeah,
viruses.
Are you suggesting that could we create another algorithm or could we use this one for like microbiology?
Yeah, for the diagnosis purposes.
Yeah, so this algorithm is specifically trained for this kind of bacteria. I mean, it could be similar in terms of size, in terms of type to another microbiology application. But I've actually tried that. I've tried using other cells, cell bio, to see how well the algorithm does with those meters. And it does box some of them, but because it's not trained specifically on that data, and it doesn't have that supervised learning experience, so that it doesn't know what is correct and what is wrong based on what you're testing it with, since it doesn't have anything similar to that in the training set. It would work to some extent, but not nearly as well as it works with this 77% accuracy on the type that we specifically built it for. But in terms of creating another algorithm that is specifically trained on a data set for, let's say, cancer cells or something, that is definitely a possibility.
Okay, thank you. Any other question?
That was a great presentation. What were the main challenges you had?
The machine learning aspects?
Yeah, all the aspects. What were the main challenges from your perspective? You have ISIS and you have instability project. So what were the in detail? Why
I would say the main thing about this project that was difficult is if I go back to yeah, a bit more to the figure with the boxes. Yeah, this one. So I mean, if you look at some of the boxes here, there's a whole like combination of different fields that this research I go into more like chemical engineering. So in terms of the challenges that I faced, it was definitely being able to both understand and apply learning in so many different fields, so many different industries, chemistry, chemical engineering, cell bio, environmental science, machine learning, AI. There's so many different things that this research encompasses that I think that is the main difficulty that I face. For example, I didn't think before this research that I was very capable with comp-sci stuff. But so I had to learn what all these metrics mean, what recall, precision, accuracy, how to actually code an algorithm like this one, train it, learn how to work with the model, or learn with the model, try to find the exact percentage, the amount that's gonna yield the best results. So I think that was definitely one of the difficulties. But as you accustom yourself to keep reading papers, and keep trying to advance your project so that you can bring it to a higher level, you can bring the whole picture to the project. I think that over time it really develops naturally.
Any other question? Okay, thank you, Esat. Great presentation.